doing the special triangles, or are you all doing the hands? Hands, great. So sine of 30. 30 is the ring finger. Hold it in. Sine is the bottom fingers. So you have 1 over the palm of your hand, 2, so it's 1/2. If you go with cosine, 45 degrees is the middle finger, so you fold it in. Cosine is the top or bottom set. Top, so it's radical 2 over 2. The palm of your hand is a 2. Tangent is 60 degrees. First fold in 60 degrees, which is what? Pointer finger, fold it in. Tangent, you flip it, and you get radical 3 over 1. Radical 3 over radical 1, but the square root of 1 is 1. Cosecant is the reciprocal of sine. So you're going to have the sine of 60. So 60, sine is which set of fingers? The bottom, which is going to be radical 3 over 2, but the reciprocal is radical 3 over 2, so the reciprocal is 2 over radical 3. If you rationalize the denominator, that is 2 radical 3 over 3. Either one of those would work. So you had a sheet. You had to finish filling out this sheet. If you want to get that second page out of your notes. You have to upload a picture. Okay, so this one, as you go down, I think we did the first column all together, didn't we?
Yeah.
Okay, the second column, 60 degrees. The top value, the sine is 60 degrees is what? Radical 3 over 2, what's the cosine of 60? 1/2, what's the tangent of 60? Radical 3, what is the cosecant of 60 degrees? 2 over radical 3, that's the same thing as 2 radical 3 over 3. What is the secant of 60 degrees? 2 over radical 1, the square root of 1 is 1, so it just ends up being 2. And what about the cotangent of 60 degrees? 1 over radical 3. You talk about 45 degrees, what's the sine? Radical 2 over 2, the cosine? Radical 2 over 2, the tangent? What's radical 2 over radical 2, though? 1. So your answer is 1. What about the cosecant of 45? 2 over radical 2. If you rationalize that, if you take the cosecant, you get 2 over radical 2. When you rationalize that denominator, what are you going to end up with? 2 radical 2 over 2, and the 2's cancel, and you're just left with, that's a nice 2. You're just left with radical 2. So if you said radical 2, that's what it simplifies to. What about the secant of 45? 2 over radical 2, which is the same thing as just radical 2. And then you get the cotangent, which is 1. So the last thing that we're going to look at on this note sheet, I am gone Monday and Tuesday. I'm pretty sure I will not be back Monday. Monday I have to take Logan in. She's got a, I hope it's a sebaceous cyst, but she's got a cyst on her back. So she's got a bump back here. So yeah, I hope that's what it is. We're hoping that's what it is. So, but I'm not going to say anything to her and make it sound like it's nothing. I don't know. So anyway, I have to take her in for that. And Tuesday, I'm in the school building, but I have to be entering in all of the NISA, well, not NISA, NSCAS and MAP scores. So I'm just going to be stuck at a computer all day, entering in a whole bunch of numbers. Not until December. Which I still need to meet with a few of you. Milo Seaver, Eugene, Wilson, and Abby. I need to meet with you to set your score sometime. If you stop in after school real quick, it won't take very long. But anyway, so I'm not here Monday and Tuesday, but I got worksheets over this information for you to do for the subs. I don't think. Maybe I'll be back Monday in time. I don't know. It depends on what all they do. Okay, so on the next page, evaluate the 6 trig functions of the given angle, and they want the exact value. So they don't want it rounded to any place value. If you look at A, they're going to give you a triangle, and they actually put the side lengths in there and the angle measures. So you have 30, you have 60 degrees, 8, 16, and 8 radical 3. So they ask you for the sine of 30 degrees. First, I'm going to ask you using that. Sine is what sides? Opposite and hypotenuse. What's the opposite side? 8. What's the hypotenuse? 16. Does it matter what those side lengths are? Do you have to be given a triangle? No. Use your finger. What happened? Did you guys write the corresponding angles or the sides down, or did you just use your hand? If you just use your hand, that's what this is going to reduce to. I don't care what ratio these are in right here. It's all going to reduce down to what's right here on your hand.
Oh, does your hand only work if it's a 45, 45, 90, and then 36?
Yes. Yes. If there are, you're probably going to have to resort to the calculator, which is not going to give you an exact value. The exact value, when they ask for exact values, you want radicals. So the reason this says the exact value, up above it says exact value in parentheses. They don't want you for the cosine of 30. What's cosine of 30? Radical 3 over 2. But what they don't want you to do is take your calculator and type the cosine as 60 in on your calculator and get that decimal value. Is it 0.77 something? Just take cosine of 30 degrees. What's that? Are you doing that, Carly, or not? 0.866. They don't want you to write 0.866. They want it as radical 3 over 2. They want that exact value. And you're going to have a hard time doing that for any other angles. Except for 30, 45, 60.
Well, we have decimals.
It's still not going to be, no, we had a hard time doing that, remember? And if there's a radical involved, it's not going to do it, and that's why it's not converting it over. It's because you have a radical 3 over 2, and it's not going to convert that over to a radical.
If you don't have one of those two triangles, we used to, like, when we, like, use Silvertone and, like, filter the letters and stuff.
What's going to happen if you have something else is you have to use identities. If you guys have something else besides a 45, 45, 90 or a 30, 60, 90 triangle, there's different things you can do to find like 15 degrees and things like that, but it gets into a whole bunch of identities. So right now, the only thing you need to worry about or focus on is this right here. So were you able to answer A and B up above on that sheet?
Yeah.
The sine of 30 is 1/2. What's the cosine of 30? Radical 3 over 2. The tangent of 30? 1 over radical 3. That's the same thing as radical 3 over 3. What's the sine of 60? Radical 3 over 2. The cosine is 60, which is just 1/2. What about the tangent is 60? Radical 3. The sine of 45? Radical 2 over 2. The cosine of 45? Radical 2 over 2, and the tangent of 45, 1. Here's the last thing that you've covered this, but I just want to touch on it again. Is if you look at question number 7A. 7A says, find the measure of the given angle. Use your trig values as special triangles. This is where I said that as you look at this, if you know those special triangles, you can get to this. But do you have to know those special triangles? No. So you're going, oh my gosh, now all of a sudden I got to notice these special triangles, and I noticed that if I double it, then that bottom angle is a 30-degree angle. You don't have to know this. You can still come up here and you look at your angle, and what two sides do you know with that angle is? The opposite and hypotenuse. Which trig function is that? Sine. So the sine of my angle is equal to opposite over hypotenuse, which that reduces down to 1/2. So then it says the sine of the angle equals 1/2. They're looking for the angle. You're not going to get a calculator. If you were to type it in on a calculator, that's what they'd be asking for when you look for that angle. If not, you want sine. That's the bottom set, right? So you sit here, oh, okay, now I'm going to do this. You talk about your hand. Oops, then I wrote it wrong. And they want the sine of 1/2. So if it's the sine of 1/2, you want one finger, so you're going to fold this in. And what's that degree measure? 30 degrees. So the answer to this is 30 degrees. That's how you can find it without even looking at the special triangle. Now the next one, if you look at 7b, that gets even a little more complicated in a way. You look at it and they say that this angle up here, angle B, is x. You have 8 radical 2, and you have 16. Well, you look over there, and do you see anywhere where a side length is radical 2? No. You see radical 2 is the hypotenuse. So we could set it up this way. The sine of angle x is equal to, not sine, what sides do you know? Adjacent. So that is cosine. So the cosine of angle x is equal to the adjacent over the hypotenuse. What does 8 radical 2 over 16 reduce down into? Radical 2 over 2. Oh, now that looks like something I know, right? You get cosine, so you want your top fingers to be radical 2, which means what finger do you fold in? Your middle finger, which is how many degrees? 45. So B happens to be a 45-degree angle. So you sit here, you have your thumb, your pointer finger, middle, ring, pinky. Here's your 2, cosine, sine. We have our 2 in the palm, which is right here. There's the palm of your hand. So here's your fingers. Here's the palm. So you want 2 fingers. So you have to fold this one in. And that's where you get your 45-degree angle. So you see how this can help you find the angle, but can also help you find the ratio between the two sides.
If that's a 45, 90 angle, I was only had the radical 2 right there.
Because here's what's happening. N is 8 radical 2, right? This is going to be N times radical 2. But this is your N value right there. So what is 8 radical 2 times radical 2? Radical 2 times 2 is 2. 2 times 8 is 16.
How do you, couldn't it also be, so we do adjacent over hypotenuse, but can you do like hypotenuse over adjacent, or like how do you?
That's going to be more difficult on your hand. You're going to want sine, cosine, or tangent. So I just look at the angle that you know. You see the angle you know? you want to read SOHCAHTOA in this direction, and that direction only. So as you do that, because I don't think you're going to say it's 2 over what or something like that. So as you look at it, you just say, here's angle X, this is the adjacent side, and this is the opposite side. So SOHCAHTOA, if I have adjacent and hypotenuse, I'm going to be using cosine.
Isn't the hypotenuse?
Oh, sorry.
Yeah, it's good.
Thank you. I knew what I meant. Abby may not be knowing what I meant.
Oh, yeah.
That's what I meant.
I was like, oh.
So that's like,
Yep. Just like this one, if you back up one, here's your angle. This is the opposite side, and this is the hypotenuse. So you go to SOHCAHTOA, and you say, okay, which one involves opposite and hypotenuse? That's your sine. So it's going to be the sine of your angle is 5 over 10. Reduce it, you can use your finger. Now, if not, keep in mind if that was not one of those, you would be using the inverse, the shift.
And you would have to use the calculator.
If it was not one of the special triangles, you would. But for right now, I think most everything you're going to be working with is going to be dealing with a 30, 60, 90 triangle or 45, 45, 90. I can tell you ACT will be dealing with one of those 2 triangles right there. So you sit at your ACT test and start doing this. You'll probably be the only one, and they're going to be wondering why. Tran kids do it all the time. I don't know other schools that work with that.
And you're like, what are these kids on?
I know. And the proctor's going to be sitting there and you're like,
He's like, what kind of
what's going on? Just don't write it on there. Yeah. So what's the top? What's the top always going to be? Cosine, alphabetical order. And all it's doing is, remember, it's referring to the unit circle, and your cosine is the x-axis, and the sine is the y-axis, and you're just finding coordinate points if you were to take a unit length of 1 and make a circle. That's the easiest construction, right? Put the point down so you're not really. People have a hard time making a circle with the compass. Spinning it around tends to be a problem. Okay, that almost caused me to start coughing again. Now remember, sine, cosine, tangent all deals with this unit circle, and we had different quadrants, and we said cosine is the same thing as the x-axis, sine is the same thing as the y-axis. So cosine is positive in these 2 quadrants, the first and the fourth, and it's negative in these 2 quadrants. Sine is the same thing as y. Y is positive in the first and the second quadrant, and negative in the third and the fourth. Yeah, because your angle measure will always be in reference down to the x-axis. So if this is your angle, this is the adjacent, and this is the opposite. Is tangent what? Mm-mm. No. It's just putting the ratio of these 2 together. It's just the fraction you get when you compare these 2 sides. So for the worksheet that I just handed out to you, which is the unit circle worksheet C, if you look at that, I'm going to go over the first few with you, and then you can do the others. But this is where we start getting into different angles. The first one. Given point P is located on the unit circle, state the quadrant and find the angle. Also, the sine, cosine, and tangent. So you got to state what quadrant they are in. So here's information you also need to know. When you talk about quadrants, quadrant 1 is the top right-hand quadrant. Then you go counterclockwise. So you have quadrant 2. I can't make it 3. You have quadrant 3, and you have quadrant 4. Excuse me. So if you look at it, here's 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then you're back over here to 360 degrees. So you can see that quadrant 3 has values between 180 and 270 degrees. Okay, as you look at the first one, they have that coordinate point of -1/2 and radical 3/2. So, oh, here's another thing. Then I said the phrase that all students take calculus. So we were making reference to what trig functions are positive in that quadrant. Now keep in mind the reciprocal functions will have the same sign value as what the top 3 ones do. So in the first quadrant, what trig functions are positive? All of them. In the second quadrant, which trig function? Only sine is positive. In the third quadrant, tangent is positive. In the fourth quadrant, cosine is positive. And if we think as a coordinate point as x, y, oh no, I'm going to start my conference call again, which means cosine sine, which means the adjacent side to the opposite side. And remember, what you always do is you draw the bow tie. So when you are making your triangle, your angles are always in reference to the x-axis. So keeping that in mind, you have this coordinate point. The coordinate point they give you is -1/2 and positive radical 3/2. So as I look at that, what quadrant is that in? You go back a half and you go up. I'm going to draw this one separately over here. So if we talk about what quadrant that's in, better change the color from my axis. There's your axis. Where's that quadrant? You're going to go back a half and you're going to go positive radical 3/2. So that happens to be in the second quadrant. So I think the first question they ask you is what quadrant is that in? That's in quadrant 2. The next thing they say, state the quadrant and find the angle. So that's quadrant 2. They don't have a mark for your angle. No. What is that angle measure? Okay, what I want, if I look at this right here, this is a key thing right here. This is cosine and this is sine. Here's another way you can look at it. Where's cosine negative and sine positive at? Sine's positive here. So that's another way you can look at that measure. The best thing to do is just figure out how you're plotting your point. But otherwise, you want cosine to be 1/2. Remember the last thing we were talking about on that handout of your notes? We want cosine to be 1/2. Cosine is the first value there. So to get cosine 1/2, which finger do you have to fold in? Pointer finger. And when you pull that in, what is that angle measure? 60 degrees. So if I were to make this triangle, here's my 60-degree angle right there. You don't, I mean, that's the next thing. They do say find that. It's a 60-degree angle. What is the actual angle measure they are talking about? That's your reference angle. I should say that's the reference angle. But what is the actual angle measure which goes right there? 120 degrees. So we are talking about 120 degrees. If you take, on your calculator, got a calculator real quick? $60 is the reference angle. But if you want the actual angle measure, you're at 120 degrees. So if you take your calculator, I want you to take the cosine of 120 degrees. The cosine of 120 degrees. And what do you get? -0.5. What did we say it was right here? -0.5. All right. Then take the sine of 100, or take the sine of 120 degrees. Now, Carly already told us that radical 3/2 was 0.86. Yep. And it's positive, right? It's radical 3 over 2. Oh, did you get it as radical 3 over 2?
Yeah.
Oh, because you got those nice other calculators, yeah. I think it's even cheaper than that. Maybe about 9 something, maybe. You type in the sine of 120 degrees, and you should get this value right here.
Where do you get 60 for sine here? Because radical 3 over 2.
It's going to be a 60-degree. Okay, here's clarification. You do get, if you take the sine of 60 degrees on your calculator, and you take the sine of 120 degrees on your calculator, you should get the same value. Because what you are talking about is you're talking about in this you're talking about these two quadrants right here, and sine is positive in both of them. 120 degrees has a reference angle of 60 when you draw your bow tie. Where else would you have that same value of 0.866 at except for negative 0.866? If I drop down here and I make this a 60-degree angle, how many degrees is this right here?
20.
Plus another 60. 180 goes half, and then if you drop down another 60, what's 180 plus 60? 240. Take the sine of 240 degrees, and you should get negative 0.866 on your calculator. Do you? Or you get negative radical 3 over 2. Now, where else are you going to have, what's another angle measure that would still have that same value, but maybe a different sign? Well, I need a 60-degree again, right? So I think about the bow tie effect, and it's going to be over here. The bow tie is going to be right there, 60 degrees. So 360 is all the way around. So if I drop back 60 degrees, this is 300 degrees. Type in the sine of 300 degrees. Sine in this quadrant is negative, so it should be negative 0.866 again. Or negative radical 3 over 2 if you got the nice fancy calculators that do that for you. So you actually have 4 angle measures that will be within that. It's just the signs are going to be different for 2 of them depending on which quadrants they're in. Yes. You just take your hand. You want 1/2 and you want radical 3 over 2. Right here's your hand. This is the top values, that's your bottom fingers. It's 60 degrees. But you have to know what quadrant it's in. So what quadrant it's in is the second quadrant. So you draw your 60-degree reference triangle in the second quadrant, and then what you do have to find is you do have to find what is this distance to there. You can either go, you got to be careful. I always go from 180 or 360. This is going to be 180 minus 60 to get up to this right there, right? To get to this one right here, that's going to be 180 plus 60. To get to here, of course, that's just 0 plus 60. And to get to this one right here, it's going to be 360 minus your reference angle, which is 60 degrees. So what is the sine? What is the sine of 120 degrees? Well, that's given to you right here. It's going to be radical 3 over 2.
But on here, it doesn't give us, it just gives us that O.
Theta. It gives you theta, but if you read up above, it says state the quadrant. So what quadrant are you in? The second.
Oh.
Then it says, and find the angle. So the angle, you have a 60-degree reference angle by using your fingers. It's a 60-degree reference angle in that second quadrant. So here's what you are doing. You're sitting here and you're looking at it and you go, okay, I have a 60-degree reference angle, but I need to know what's this angle. So this is one. Well, you use this to figure out 60 degree, but then you want to know what's this right here. So what is it if you go all the way around there? 180. How short are you? 60 degrees. So what's 180 minus 60? 120. And that's your angle measure that you have. Now we're not going to do 120 235. We're not going to do those on our hand. This is just your reference angles with your bow tie. So you go back to 60 degrees and it says, what is the sine of 120 degrees? You think to yourself, 120 has this figure right here, and I'm talking about, I just lost it. This figure right here, cosine is adjacent and sine is opposite. I don't know what is the sine of 60 degrees. It says 120, but remember when we did this, each one of these that we typed in here, 60, 120, 240, and 300, what was the only difference on your calculator? Positive or negative. Because each one of those has a 60-degree reference angle. So you're still thinking 120, you go, oh, that's a 60-degree reference angle. The sine of that is radical 3/2. And students, sine. Sine is the only thing that's positive in that second quadrant, so that's going to be a positive value. You can get it from this right here, from your coordinate point. The next thing they ask you, I think, is what is the cosine of theta? But I found that angle to be 120 degrees. What is the cosine of that? Well, it's 1/2, but it's negative. Cosine is negative in that second quadrant. So it's negative 1/2, which we have right there. And then they ask you, what is the tangent of 120 degrees? Well, the tangent of 120 degrees, you have that 60-degree reference angle, flip it. What do you get? Radical 3/1. So I have radical 3/1, but if I talk about all students take calculus, the only thing that's positive is sine, so what's this answer going to be? Negative. The other way you could get to it is you could say tangent is opposite over adjacent. Well, guess what? Tangent being opposite over adjacent, look at this. It's the same thing as sine over cosine. What is sine? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And to divide fractions, you keep change flip, and hypotenuse cancels, and you get opposite over adjacent. So you could just divide those two.
Probably gonna have questions.
You will do the worksheet that's handed out to you first on Monday, Tuesday. Don't lose this sheet. Good luck this weekend. Have a good evening. Drive safely if you're going to the game.